Hello. In this video, I'm going to provide some information on technical report writing, specifically a document writing for the purpose of thesis, undergraduate graduation project or graduate thesis or something. When you look at the internet on YouTube, you find a lot of videos, but a lot of them describe too many details for the starters, for the story part of it. Here, I'm going to go through an example and emphasize the critical parts, mainly for engineering report writing or engineering thesis writing. First of all, for the engineering thesis writing, every school has a cover page form that is designed by the university. For example, at a specific university that is shown, they have the name of the author, the student, the name of the thesis, the name of the school, the graduation date, and the type of the thesis that is. So you have to obtain that document in the proper format and integrate to it. That's relatively an easy task, but you cannot keep in mind that there are specific formats that you cannot violate. And the signature pages and the abstract, and then comes the acknowledgement, and all those are kind of common documents that you can find samples and you can just edit to them, or you can just write your own, but according to a specific format. The following things are the index, the table of contents, the contents, the chapter by chapter, what's in the thesis. Again, this has a format showing the titles, the subtitles, the number of pages, all in detail, so that the reader of this document later, when necessary, can easily go through this index document pages and easily identify what they really want to do. And then they go focus on the related pages. And there is a list of figures. All here we have the figure numbers and the pages that they exist in, and the title of each figure. I'm going to discuss with you those later. So depending on the document size, these could be a few figures or a few tens of figures, or if it's a long book or something, it could be up to a couple of hundreds of figures. Then the tables, list of tables, depending on what you do, you may have large number of tables or small number of tables. But anyway, you finish all the index, and now you come to the thesis or to the report, the main parts, the meat of the project. Then you have to go chapter by chapter. Either you use the Roman Rackham numbers, or you use the alphanumeric numbers. You have to number things, and when you do the numbering and when you do the captions, you should not do arbitrary, in the sense that in one chapter you write capital letters for the title, in the next chapter you write small letters, in the other one you cannot do this arbitrarily. Whatever you do as format in one, throughout the full document you have to do the same. So you have to check your document for consistency. And what should be the format is basically there are appropriate forms that you can observe and learn from. For example, you can go with capital letters for the titles, and then you can go for first letters of each word are capitalized as the subtitles. And then you go with numbering. For example, chapter 1 is one chapter that has the title of introduction, then the sub titled first part is 1.1 with a title of switch mode power supplies, and then let's see, we go to 1.2 and then again the caption for the second part, and we go on and on. When we include figures, every figure should have a clear illustration, then every figure should have a figure caption. That is the figure number and then the figure title. What this figure is about should be described. In certain ways, this is described as a sentence and it's capital, it's basically it's ending with a punctuation. In certain cases, it's ending without a punctuation, indicating that this is not a sentence. Throughout a full document, you either use one form or the other. Which form do you use depends on the forms recommended to you. Typically for engineering, we use the IEEE standards, the IEEE documents, and we go with that. You see another figure here has a figure caption. If you have two pieces in the figure, then you have to subtitle them as A part and the B part, and then you have to refer to them in the document figure caption as A part and B part, whatever they are, you have to describe in here. And when you refer to them in the text, you see here it says figure 15A, this referring to it. So once you have it, you cannot say that it's something in page something that you have to, when you discuss whatever graphic is in here, you have to refer to it in the text as figure number 5. The switching circuit that is shown in figure 15A is short, for example. Here you see in chapter 2, we use, in this case, alphanumeric, we go chapter 2, which will be described the title here with capitals, and we start with the sub pieces as the word as describing definition with the initial capitalized. And then we put 1.2.1, 2.2 and 2.3, and we progress to the document. I'm going to go through the document to a point where I can obtain another piece of, here we have equations. We have all the equations should have a number. That this number should be numbered according to the chapter. Chapter 4, if chapter 4 has 4 equations, the first equation is 4.1, the second equation is 4.2, the fourth equation is 4.4. Then it should be aligned and it should be numbered with 4.4. Then when you refer to the equation in the text, as you see, from equation 4.5, the output filter inductor value is calculated. That's the way to do it. Here is, for example, a flow chart. In engineering, many times we have processes that depend on each other. And in order to illustrate them, we use flow charts. When we use flow charts, these are actually considered as figures. We have to illustrate them with all the directions of what happens in one way. If I go in one way, what happens in the other. Then this is described as a figure, should be illustrated clearly. Then it should be given a figure title and a figure number and figure caption. The next thing is a table. In engineering, we use tables to describe numbers that relate to certain variables or certain parameters, to define certain numerical conditions that relate to certain conditions. In that case, when we define a table, the table should have a header and should have basically the table caption as the number of the table and then the definition of the table. This is the caption part of it you must have. Then when you have the table, when you have basically numbers and variables, you have to assign them to each other clearly. If you leave that without a frame and without windows clearly defined, if you leave it just as text, blank, then it's very inconvenient to the eye. It's uncomfortable and it's sometimes easy to cross over, identify the terms wrong. So it's always preferable to have a box. When you use the word processor, it gives you basically borders and boxes and things options. So when you define a table, you should define it with the lines and the rows and the columns that separate the components from each other, so you can easily see. Here is another table. When you have physical equipments in engineering, especially in graduation projects, you do have a lot of hardware to illustrate. So you should, when you take a photograph to illustrate something, you should make it visible, easy to understand, that this device has input terminals which are on the left, output terminals which are on the right. Many times, in order to give a sense of dimensions, you can put close to it a comparable size, something, a matchbox or a pen, to illustrate a relative, or you can also use a ruler to give you an idea about the physical dimensions of this. And it's always a good idea to take the photograph from an angle to give the third dimension idea about what this device looks like. When you take the photograph, you have to look for the way the light comes on, so you should not have too many shadows or too much shadow. Or if you have too bright light, it will look very high contrast picture where you will not be able to see the image clearly. So you have to do certain work and check it, see if it looks good to the eye. Typically, it's good for presentation. When you have experimentations in the system and you want to put the graphics, there are two ways. One is you can transfer the graphic as a graphics format from an oscilloscope or from a computer screen, and then you just paste that image as is. If you take a photograph of it from a distance, then you should adjust the light and the angle of the oscilloscope screen and make sure you have enough light and you have it from a proper angle so things are visible. But no matter what you do, when you take these photographs, the graphic itself may have limitations. You may not be able to understand the scale of the physical quantities. So if the scales are not visible or understandable, then you have to describe the horizontal line. What is a horizontal square in time? For example, on the horizontal axis, we have time. On the vertical axis, we have voltage and current, something. So if we are measuring quantities, we want to know, as a person who looks at the graphic and tries to understand, uh, we want to know what is the square in terms of microseconds or milliseconds, whatever. In this case, it is illustrated as 5 microseconds per division. So I know I have 5, 10, 15, 20, 30, 25, 30, 35, 40, 50 microseconds, a full cycle. This means if I have in one cycle 1, 2, 2.5, we have about in 5, 10, 15, 20, we have 20 microsecond cycle of the signal, then we know this is a 50 kilohertz signal. Otherwise, we will not know the frequency of the signal, and then we will not be able to interpret. Likewise, vertically, what is the magnitude here? For example, the blue waveform, which is the current, has a scale of 5 amperes per division. This is how we describe it. So this means I have 5, 10, 15 amperes peak. In 15 amperes minus peak, this means we have 30 amperes peak to peak current value. Then we have a good understanding of the waveform, which is 50 kilohertz and 15 amperes peak or 30 amperes peak to peak. So we can understand the signal and then we can interpret it. So when we write a document, we want to make sure that the reader who reads this document can understand the graphics, what these mean in terms of the physical quantities. When we have, in certain cases, when we have a large physical circuit diagram, instead of placing it as a vertical page document, we can place it as a landscape form. Then we can rotate the page, and then we can have a large view of a full circuit with comfort. So these are all things that can be adjusted with the Word document or LaTeX document, whichever you prefer. You'll always have options to improve the visual visibility of a document. It is many times useful when we do hardware. We can do part by part, illustrate a small part of it, then a larger part of it, then we go look from a distance to the whole physical system and take a kind of global picture of what this project is about. So on the one hand, we go and show the oscillograms of the waveforms as we had, let's see, in here. On the other hand, we show some pieces of hardware depending on basically what we do in the project. We illustrate things piece by piece, then we go illustrate them as whatever in terms of the waveforms at the output, waveforms at the input, input and output together on the same graphic screen, because many times we have to coordinate quantities with each other. We have to correlate them. And then if we have individual waveforms on each graphic, then it's very important to align these waveforms. It's better to integrate all of them in one oscillogram if you can. Then you can illustrate and relate at t equals t0, what was the voltage, what was the current, what was the other component at the same specific time. So it is important when it's necessary to include as many waveforms in the same oscillogram as possible. When you have a waveform with only one variable, it may be possible to include only a monochromatic black and white view. But when you have multiple waveforms, then if you have the option, you should go with multicolor so that it's easy to see and distinguish different quantities from each other. When you write the document, you do basically the introduction and the development, depending on what it is. You may have multiple chapters on the development of the work. Then you come to the conclusion. The conclusion itself is a chapter also. So here in this document, the conclusion is the final chapter, and since it's only one piece, it doesn't have a subsections as 7.1, 7.2 whatsoever. And when you go to the references, you should not arbitrarily write references. There is a format of writing the references in terms of books, in terms of papers, in terms of reports. When you access things from the internet, there is a way of representing every single one of them. And the best way to do that is to go through IEEE documents of recent times, IEEE papers. I will show some of those in a while. At the end of the report, typically, if we have a piece of information in the document that if we include it within the document in the main flow, if it is not essential and if it is too much to lose focus, then typically this could be deriving equations, proving certain concepts, describing a code, a long code that does certain specific tasks. For these, what we do is we use the appendices. In the appendices, we can include codes, we can include certain theorems, we can include certain design procedures. So anything that is not essential for the main flow is used in the appendix. So there could be multiple appendices and could be Appendix A, Appendix B, and C. In this document, the engineering student had to design circuit components and various components. So every design was a specific task. For the first task, he had the Appendix A, and he wrote the code that calculated certain things. Now, with the code, it's a important thing to describe what this code does, who did it, at what time you did it, and then describe the input quantities to the code and the output quantities from the code, and then describe the code itself. Here is another code that does calculation of something in a project that, again, has the same format. So through this long document, there are some critical things that I wanted to discuss. Typically, engineering projects, when reporting, refer to a problem. So whether it's a table or it's a graphic or it's numbering of the equations, there are very frequent mistakes made in relation to that. Now I'm going to go to another path to discuss the IEEE documents. This is a paper that we have published with my students a couple of years ago. It's relatively fresh. So in here, actually, this is a very different type of document from a report, but in essence, it's the same. What's the difference? Well, this is a double column format paper rather than single column, and the page spaces and the distances and the fonts and all those may be somewhat different. But what is not different is there is a title, there is the author information, there is an abstract, there is chapter by chapter the material, the section by section the materials are described. Then there is basically the figures, then there's the figure number and the figure caption. In that way, everything is the same. There are graphics which have the same issues. Let's see, we have in this document, we have tables. IEEE has certain recommendations for making tables. When you have experimental system, you have something similar. The reason I wanted to go to this IEEE document is through it, actually, towards the end of it, I have a list of references, how you can do referencing. The best way to write references is to go look at IEEE literature and learn from their ways of writing the references. How you refer to a conference paper, how you refer to a journal paper, how you refer to a book. There are always examples in many papers written. As you see, the equation numbering, equation formatting is very similar to a thesis that I showed you. In there were chapter by chapter descriptions. Since this is a short paper, the equations are numbered according to the paper, starting from the first equation as number 1 to the final equation as the 23, whatever that was. So there are small differences between a paper and a thesis in terms of report writing, but the main stream, the main line of putting the figures, labeling them, putting the tables, labeling them, putting the equations, labeling them, and all that is almost 100% the same. The other thing I wish to tell the students is let's say you are a non-native English speaker, you have developed certain writing skills. Well, nobody is perfect. I have been writing papers in English since 1990. So 33 years of writing a lot of papers and theses and documents. And I still have difficulties in certain ways of expressing myself, writing the proper sentence, writing it with the proper grammar, writing it in the proper shape. And even when we write them, we have the way we use the format as double spacing or 1.5 spacing or single spacing between the lines, and whether we terminate with free format or we have alignment, the left and the right of the paragraph, whether the paragraph starts with an indentation always the same way, or do certain lines have any exceptions? These are all to be learned from the resources, either taking a reference document as a resource or going to the internet and going to recommended reference documents and progressing through them, learning from them. I use certain resources. For example, in the back, you see a library, a bookshelf. At the top right, uh, there are certain resources. One is dictionary from the old days, English, English, English, Turkish, Turkish, English, and certain foreign languages also. We used to use those. Now you have Merriam-Webster dictionary, which is very powerful. There is also the dictionary, which is called the thesaurus. What this one does is when you write a sentence, when you want to explain a phenomena or an event or a specific situation, you may not know the exact word to describe that situation. You know some words that are close, but that's not exact. So what you do is you go to the dictionary of similar words. The dictionary of similar words is basically thesaurus, or it's called the one famous one is called Roget's thesaurus. So if you go to that and type the words that you know, that tool is going to give you the words that are related to it. And from those words, you will pick the one that exactly matches the meaning that you are looking for. I also use the Technical Writer's Handbook. There are various of them from the internet, I'm sure you can find. What those guys help you with is with the grammar, with the way you use your conjunction, with punctuation. So every time when you encounter something, if you are facing a challenge and you try to do it by memorization and you cannot figure out the rule, you see something here done in one way, something there is done in another way. The best way is to go to a good quality handbook. Let me see if I can. From here, I will show you my resources. This is, for example, the writer's handbook for the technical writers. Actually, this is not for technical, for any writers, social or technical. I used this in my very early days. Then I got this handbook of technical writing. This is something that I use in later years, and I learned a lot from it to write literature. If you want to write a paper in Turkish or in any language, but you're not so comfortable with English, there is a publication by TÜBİTAK. Bilimsel makale nasıl yazılır, nasıl yayımlanır. Here they provide you a lot of resources, information on how to do it. Then there is this dictionary of similar words. This is Roget's thesaurus. These are some of the resources that I have been using. And whenever there is something I don't understand and I'm not comfortable with, I go refer to these things and I solve my issue and I continue to my writing. So what I truly believe is writing is some people are naturally skilled to write, some are not, but everybody can write and everybody can write to a sufficient level. The good ones with effort can become perfect. The poor ones with effort can become sufficient. And if you are an engineer, you're going to write. And when you write, if you want your effort not to go waste, then you should do it good. And for that, you have to work hard. As the more you write, the better you will get. The better you write, the more your work will be respected. And then you will get more ambition to do your next writing as better work. And I would say in developed societies, people write. In underdeveloped societies, people don't write. In developed societies, first people read a lot and they also write a lot. In a society where people don't read and don't write at all, the progress of the society becomes very low. So if you want your engineering society to progress, if you want to leave good marks behind, then you should definitely learn to write. You should, in this modern age, you should also be able to create video recording of your work in support with the documentations that you provide. So you put information on information and expand the information geometrically. You know that information creates information and the growth is not linear. It can be cubic, it can be at higher order, depending on how you generate and expand the information. So all I want to say is writing is important, and as professors, as engineering leaders, as project leaders, as those who have worked with people in engineering world, whether it's in academics or in industry, we always respect well-documented work. Anything that has been hidden is usually forgotten and lost in time. Anything that has been documented, if it has a value, its value increases with time. So we highly encourage you to learn how to write and then generate good things and write them. This short presentation has this purpose of providing you some guideline, not teaching you everything, but providing you guideline how to go through some of the critical steps and then progress. Bye.